These are the Module 11 Part 1 notes. We're talking about random variables and probability distributions. So through Module 11, the material gets more mathy. We still will use Excel for the larger sets. I will do smaller sets by hand, knowing that you can use Excel, hoping that this helps it make a little more sense. Okay. So we are going to start by reviewing what we know about random variables. We are talking about numerical measures. Okay, so we are not talking about qualitative variables at this point on. For the immediate time being, we are talking about numerical or quantitative variables. Okay. We talked in the past about types of quantitative variables. We're going to focus here on whether something is discrete. We've got whole numbers or countable values or continuous, so something that spans an entire range of values. So example 1 here, we want to determine whether the random variable speed of the next car that passes a state trooper is a discrete random variable or a continuous. So even though our speedometer reads in numbers, partial numbers, whole numbers, we really could be clocked on that continuous range, right? They could get us going 75, 75.1, 75.2. The thing to remember about continuous variables is that you have to pass through all the values between two numbers to get from one number to the next. B, determine whether the random variable hair color is discrete or continuous or neither. This one is a neither, right? This is not numerical. And while we could assign numbers to hair colors, there is nothing that says because we are calling blonde 1 and brunette 2 that brunette is better than blonde. So we could assign numbers, they don't necessarily mean anything. C, determine whether the random variable number of credits taken per semester is a discrete random variable or continuous. That is discrete. Credits are whole number values. Okay. Another review here of what we mean when we talk about sample space. We're tossing two coins. We want to list the sample space. Just a reminder that the sample space is all possible outcomes. If we are tossing two coins, we could get a head and then a head and a tail and a head, or a tail and a tail. So 4 possibilities. We are going to call our random variable x, and x here is going to be the number of heads that we get from tossing the two coins. Okay, so I could get 0 heads. That happens, let's see if we can color code here. With this tail. So our probability is 1 out of 4, or 0.25. We could be looking for 1 head. This can happen this way, head then tail or tail then head. So we've got 2 over 4, 0.5. Our last option here is 2 heads. There's one way for us to do that. If we add these all together, we get 1. Okay, and here is what is important for us. This table is called a discrete probability distribution. For it to be a probability distribution, the sum of the probabilities must be 1. So just a reminder, our notation here, P of x, means the probability of x. We will try to remember to always add those up, make sure they add to 1. You're not going to get a trick question. You're not going to get something that does not add to 1. But just as a reminder that our probability distribution must include all possibilities, and therefore all of our probabilities have to add to 1.